Hello everyone. In this video we are going to solve the problem number 1.26 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A point moves in the plane xy according to the law x is equal to a sine omega t and y is equal to a times 1 minus cos omega t, where a and omega are positive constant. So let us say the x and y coordinate in the xy plane is given as x is equal to a sine omega t and y is equal to a times 1 minus cos omega t, which is representing the motion of the point. Okay, and here a and omega are positive constants. Now in the first problem, it is asked to find the distance s traversed by the point during the time tau. Now if we see the position of the particle or the point at the time instant of t is equal to 0, so let us say at t is equal to 0, we can write x is equal to a sine omega into 0, that is equal to 0, and y we can write it as a times 1 minus cos of omega into 0. So from here we will get 0. So the initial position of the point at the time instant of t is equal to 0 is 0 comma 0. Now at time t is equal to tau, we can write the position is equal to a sine omega tau and y is equal to a times 1 minus cos of omega tau. So these are the positions we got, that is a sine omega tau comma a times 1 minus cos of omega tau. So this is the position at the time instant of t is equal to tau, and 0 comma 0 at the time instant of t comma t is equal to 0. So basically if we draw the position vector, then this is the displacement we will get. This is the displacement. Let us say this particular point is O and this particular point is A. So from O to A we can directly find the displacement using these two coordinates. Now in this particular problem it is asked to find the distance. For that we have to find out the speed, and after finding the speed we can integrate the speed with respect to time, and then from t is equal to 0 to t is equal to tau, and from here we will get the distance. Okay, so we are having the position vector, that is, let us say r vector is equal to xi cap plus yj cap, that we can write it as a sine omega t I cap plus a times 1 minus cos omega t j cap. Okay, and in order to find the velocity we have to differentiate the position vector. So let us differentiate the position vector with respect to time. So d by dt of a sine omega t I cap plus a times 1 minus cos omega t j cap. Okay, differentiation of sine omega t will be omega times cos omega t. So we will get a omega cos of omega t into I cap plus a times differentiation of 1 is 0 and differentiation of cos omega t will be minus cos omega t. So we will get plus omega of sine omega t into j cap. So finally we will get the velocity vector as a omega cos omega t I cap plus a omega sine omega t j cap. So this is the velocity vector we got. Now in order to find the magnitude of the velocity vector, or speed is equal to magnitude of velocity vector, that is equal to, as I cap and j cap both are perpendicular to each other, so we can take the square of these two components and then take the under root. So a omega cos omega t whole square plus a omega sin omega t whole square under root is equal to a square omega square cos square omega t plus a square omega square sin square omega t under root. So from here we can write it as a square omega square sin square omega t plus cos square omega t under root. And from here we will get a into omega, as sin square omega t plus cos square omega t is 1. So this is the value of speed we got. Now in order to find the distance, we have to integrate the speed with respect to time. So we can write distance is equal to speed into dt, integrate from t is equal to 0 to t is equal to tau. So from here we will get a omega into dt, integral t is equal to 0 to t is equal to tau. So from here we will get a omega t 0 to tau. So we will get a omega tau as the distance traveled by the point. Okay, so this is the value of distance we got. Now in the second problem, it is asking to find the angle between the points velocity and the acceleration vector. So let us write the velocity vector that we have found out here, that is equal to a omega cos of omega t I cap plus a omega sin of omega t into j cap, and the magnitude of the velocity vector we got as a omega. Now from here we can find the acceleration vector, which is represented by w vector, that is equal to dv divided by dt, that is equal to d by dt of a omega cos omega t I cap plus a omega sin omega t j cap. So the differentiation of cos omega t is minus omega sin omega t. So we will get minus a omega square sin omega t I cap plus differentiation of sin omega t is omega cos omega t. So we will get a omega square cos omega t j cap. Now if we find the magnitude of the acceleration vector, then we can get minus a omega square sin omega t whole square plus a omega square cos omega t whole square under root. Okay, so from here we will get a square omega to the power 4 sin square omega t plus a square omega to the power 4 cos square omega t under root. So from here if we take the common, that is a square omega to the power 4, we will get sin square omega t plus cos square omega t under root, and sin square omega t plus cos square omega t is 1. So from here we will get a square omega to the power 4 under root, that is equal to a omega square. So this is the value of magnitude of the acceleration we got. Now in order to find the angle between, let us say this is velocity vector and this is acceleration vector, so the angle is this one. So cos theta we can write from the dot product, that is velocity vector dot acceleration vector divided by magnitude of the velocity vector into magnitude of the acceleration vector. So from here we can write cos theta is equal to velocity vector is a omega cos omega t, a omega cos of omega t I cap plus a omega sin omega t sin omega t j cap dot product with acceleration vector is minus a square minus a omega square sin omega t I cap plus a omega square cos omega t j cap whole divided by magnitude of velocity vector is a omega and magnitude of acceleration vector is a omega square. So from here we will get cos theta is equal to minus a square omega to the power 4 sin omega t cos omega t plus a square omega cube, sorry, here it is omega cube, into sin omega t cos omega t whole divided by a square omega cube. So from here we will get sin omega t cos omega t minus sin omega t into cos omega t times a square omega cube divided by a square omega cube. So that means cos theta is equal to 0. So the value of theta will be 90 degrees. So the angle between the velocity vector and the acceleration vector is 90 degree. Okay, I hope the entire problem is clear. Thank you.